let's go see what's up with that. The spot that's being reported as a wildfire to the north, I can understand, but this one here, just huge. Now, let's go on. Carbon dioxide. Oh, look at that. It's gone, guys. It's off the feed. It's gone. Let's take it back. Wow, it's gone. It's gone, gone, gone. Guys, it's gone. Let's go back 3 hours. Three hours ago, there's the leftovers. Wow, okay, it was just a sudden blast, sudden release. Let's go back another 3 hours, 6 hours ago, there it is. Okay. And the parts per million on that were topping out in the 520 range, 400 upper fours, 520 parts per million, 516, and now it's gone. Boom, poof, huge blast of CO2. Now CO2, not associated with wildfires. Hello, everybody. It is 10 o'clock p.m. Central Time on July 5th, 2016. I want to welcome everybody here into the live stream, where we're covering the most recent earthquakes to develop since last night's update at 10 p.m. and to confirm the areas which are named in the earthquake forecasts, which are issued on my channel and here on the live stream. Now that we're doing earthquake forecast each night at 10 p.m.
United States and Canada, and this is going to get us right into tonight's update. Since last night, we're currently looking at the most recent earthquakes 24-hour feed from the EMSC. I'm going to turn on the USGS last 24-hour, and we'll turn this down to see all the smaller earthquakes and the larger earthquakes in the United States and internationally. Most of my viewers are in the States, so I will address the States first right off the bat. We need to look at the 4.3 that struck off the coast of northwest Oregon. I guess that's West Oregon, technically northwest Oregon, and off southwest Oregon's coast, 3.1 and a 4.3. These are noteworthy earthquakes to strike. We haven't seen any activity strike there in a while, and it's the silent zone I was talking about in last night's update, telling you guys to watch for a 4 to 5.0 earthquake to strike in the next 2 days in this location. And now the 4.3 and 3.1 struck right in between the two clusters of movement you see on the screen right now. In addition to that, since last night, the northern border of Arizona near Nevada, where we were talking about this whole last week, finally got hit north of the Ewan-Carrette volcanic fields. And my mouse might not match up on the screen here, so I'm going to do something and turn it on so that everybody can see my full screen. And we're going to go look at Earthquake 3D and look a few of these up. Now, you're not going to see the view count up in the upper right-hand corner. All that stuff's going to disappear for a second. But it's really important to show you the earthquakes which struck since last night. Since we were watching off the coast and off the coast struck, we now need to watch in new additional areas to the east of the 4.3 that you see off the coast and to the southeast. Now, Los Angeles has not been hit yet. As I zoom in on these cluster spots, it looks like a jumble of earthquakes, which it is, and many of these over to the east, everywhere from eastern California over, is striking at a dormant volcano. Okay, every single one of them. And then down here to the south, of course, this is Salton Sea that's reaching up towards Los Angeles with multiple earthquakes creeping up the fault zone from the magma chamber that's rising northeast of Salton Sea. And as I'm talking right now, if you hear dings or booms or rumbles, that's new earthquake striking as I'm talking. Additionally, up and down the coast, the fault zone moved from San Francisco south all the way to Coalinga with the 2.4 at the pumping operation, which we would expect to see the pumping operations move at the same time the dormant volcanoes are moving. So it's a lot of activity in the last 24, and now the 4s strike right off the coast where we warned you. Additionally, to the east, fracking operations struck across Oklahoma yet once again, and just south of me, the 3.0 you see on the map, New Madrid seismic zone. And we'll get into all that in a second as well. But first things first, let's discuss about the area down here in Los Angeles. Look, it hasn't been hit yet. The location we were watching to the northwest has been hit. Many of you were tuned in because you live in Southern California. You're concerned about what size earthquake to expect. Well, just like the 4.3 off the coast here to the north, we were basing that on all the 2s and 3s to the south and the smaller earthquakes, 1s and 2s, to the north. And the combined total between them added up to that 4.0 range. So you would expect to see a larger earthquake that's pushing all of this to the east. So not only will it strike it to the east, but it'll strike to the southeast laterally down the coast, and it should strike in the silent zone, which puts us right down into Los Angeles. There is another nearby silent zone, but I think this pressure here may have alleviated it here off the Oregon coast, which is the Gordo Escarpment in northwest California. But everything to the east is moving, proving that the plate is being pressed all the way as far east as the New Madrid seismic zone. So to the east in the United States, along the edge of the craton, now that the 4 has struck to the northwest, we have to watch for similar movement to the east. It doesn't lose much steam on its way east. So when the 4.3 is now pressing due east or east-southeast, it puts Yellowstone back in the mix. Yellowstone is here on the map in northwest Wyoming. Also, southern Colorado back into the mix for the next 2 to 3 days. Additionally, western Texas, Fort Stockton most likely will start to see new fracking earthquakes, and the fracking earthquakes will pick up in size and magnitude and frequency. The number of them will pick up across Kansas and Oklahoma. Now, what's starting to worry me is that the pressure is not fully alleviating here at the fracking operations anymore. Instead, it's pressing to the east and hitting at the New Madrid over and over again. This is the most earthquake activity we've seen at the New Madrid in the past couple weeks, in the past, I don't know, at least last 2 to 3 years, which means there's an increased pressure that's pressing to the east. It's bypassing the fracking operations and going over to the east. Now, that may be happening because they've drawn down well pressure at many of these wells to prevent the earthquakes. Well, the earthquakes were relieving the pressure for us here in the New Madrid and the Wabash Valley's seismic zone going into the Midwest, which means we could see larger earthquakes start to develop in my own backyard, about 150 miles south of my location in St. Louis, Missouri, which is not good news. This is a new development that we're starting to see more earthquakes strike on the New Madrid than we have since 2011 or at least before then. So that's something we're going to have to watch going forward. And additionally to all that, it will press up the East Coast. Now that it's slipping past the fracking operations and hitting us, well, that means it's going to build on East Coast as well, which means the next couple days, we're going to see this movement fan out to the East Coast. With the new mystery booms and rumbles, they're getting reported every week now on the East Coast. Well, that's coinciding with the small earthquakes. They're not going to be so small now that they're pressing to the east past the fracking operations, so the pressure will transfer all the way over to you on the East Coast. And you need to be prepared. You need to pay attention to the earthquakes in the Midwest. They're like the warning sign that's coming your way. And on the West Coast, you can ultimately pay attention. If you're on the East Coast, you can pay attention to the 4.3 on the West Coast and watch it come towards you. Now, it just kind of, you can look at the screen here and see the large activity on the West Coast, the moderate activity in the Midwest, and the lighter activity to the East Coast. and that happens every single week. So the silent zones are the spots we watch. The older earthquakes are red, so let me get those off the map here and just show you the younger earthquakes. So the spots in between where we've already seen movement and the spot which should move are silent. And that means, of course, the next several days, those are the areas to watch. Now, let's get into Canada. Before we go internationally, we need to look at something that's been going on up in Canada, and I'm going to bring up on the screen here something that Annimatronic shared with me, if I still have it. All right, so you see this picture here? This is a giant plume of smoke coming from northern Canada. Now, on its own, you might say it's just a wildfire. I wouldn't blame anybody for just thinking that that might be a wildfire. I would think it's a wildfire, normally speaking. Here's a greater picture. But I'm going to bring you over to Google Earth and show you what we found here. And this leads into the post that I made over on Facebook, letting people know to tune in tonight because there was a big discovery that we made. Okay, so here we are on Google Earth, and we're zooming in on northern Canada. Now, the spot which is showing the burning, the spot which Annimatronic took a screenshot of the actual plume of smoke being recorded by the MODIS satellite, is very helpful because it lets us know, of course, there's a huge smoke plume there. But let me take you over to the earth.nullschool.net wind feed map, which is showing us our sulfur dioxide levels, also showing us our carbon monoxide levels. Let's turn those on first, since that has to do with fires. Now, this is a somewhat older view. Let me bring this forward to current, since I already scrolled back in time. And let's bring it forward again, and again, and again. This is taking us forward into a projection. And we'll take it back to July 5th and bring this back just ever so slightly. There we go. Here's July 5th at 4 local. We can bring it forward a few hours. 7 local, 10 local. So this is as of 10 minutes ago. And you can see a new large plume of carbon monoxide is being detected from the burning particulates. The burnt particulates and the smoke that's expended there also produces carbon monoxide from the fire. Now, let's turn on CO2, carbon dioxide. See this? This is not normal for a wildfire. This is a new plume of carbon dioxide that's showing up right now live. Now, I can take this back a little bit. Let me just minus this back. You guys can watch the time and see that it turns. Let's see. See this? All right, so this is, we got a color key down here, and we can see that blue is extreme intense carbon dioxide gas. Now, carbon dioxide is not produced by wildfires. It's produced usually by burning petroleum or by volcanic releases where there is carbon dioxide emitted by Mother Nature. So let's turn this back off so you can see the blue particulates. I can click on it and it'll give you your parts per million. So we got up into the 500 range, 515, 520 range here south. Now, the other wildfire supposedly to the north is not producing any of that. This is unheard of. Now, let me take this down to the SO2. This is sulfur dioxide. Now, sulfur dioxide is not produced by wildfires. It's only produced by either volcanic activity from magma processes or from burnt petroleum products. That's why we see large sulfur dioxide emissions from areas like New York. Let me back this out and show you New York. Here we go. Here's New York over here on the East Coast, fanning out. Here's LA down here. I mean, we're talking about amounts that are greater than New York or LA being emitted across the whole area, and it's not all wildfires there. See these 3 spots down over the Great Lakes? Each one of those is a strip mine. And I did this last night. I went in and zoomed in on the location and showed everybody what was here. We could do that again if you guys are curious about what's here. The way you do this, you just click on the Earth Null School map, grab the coordinates by right-clicking on them, and then go over to Google Earth and paste them in. It'll take you right in on where this sulfur dioxide plume is coming from. Boom. See this? We have a sulfur dioxide plume coming from a large mining operation, and it's your guess as to mine as to why it would be coming from there. I can only tell you that Sulfur dioxide is produced by either magma or burning petroleum products. And we're talking about a huge amount, an amount that would equal all of New York City. And it's spread out. Each one of these, again, is a different strip mine. And you guys don't believe me, you can go look it up yourself. earthnullschool.net. People are posting the link in the chat room right now. Now, the other way this ties in, let me take you back over to Google Earth and show you how this ties in with the supervolcano that's at this location. Now, I'm calling it a supervolcano because the shape, the sulfur dioxide emissions, now the burning material right towards the center of this, and when I show it to you, it is undeniable. And we'll back this out, and we're looking at an altitude of 2,516 miles up. So I'm zooming in like we'd be zooming in on a satellite view, and we get into about 388 miles up. And you can sort of make out the circular nature on this, and I can back it out just a little bit. But when I show it to you, once I show it to you, you will see it, and you will see it forever. This isn't like seeing faces in rocks or faces in clouds. I'm going to do a line measurement tool, and we're going to go across this circular formation from the depression in the lake. Let me just click on there, and we'll take it all the way down. And I'm going to show you the curvature before we do that so that you guys can understand what I'm talking about. There's curvature that's going on here, and it comes down, it meets down here, bends back up to the north, comes back around and over, and it forms a dome shape. And if we take the dome shape and we measure it from side to side, we get out to where the bend is. Down here, we get out at about 230, 240 miles. It starts to bend a little bit further back, so 215, 220, but at about 230. There, across that way. Now, let's measure it from this way to this way. And we get about 200 miles across. If we take it out just a little bit further, let me show you the striations so that I can prove to you that it's still circular shaped this far out. So we get out to about 220. Could go a little bit further, might be weathered over time. But there it is. Now that's not a depression. This is a circular shape. Now I want you to pay attention to the number in the lower right-hand corner. Down below where it says Google Earth. I'm going to move my mouse down around over here. You'll see it. Moving around, see how it's going around between EL, EV at about 1,000 feet, roughly 1,000, 1,200 feet. We're just moving around. You can see it all over the whole area. It's between 1,100 and 1,200, possibly 1,300 feet. As we go west across this dome, look how it rises. Rises up to about 1,700 feet. Then as we go back down, it goes back down to 1,000 at the lake. 1,000, 1,100, 900, somewhere in that range. So 900 on all sides. Same with down here to the south down here. When you move your mouse around there, you can take it all the way up to the north, and we get out to the 1,000-foot range once it slopes down to the south. So this is a giant dome. Now, is it a supervolcano? It might not be a supervolcano. It might be a bulge in the actual crust. It's greater than a supervolcano. A supervolcano is only, like, for instance, Yellowstone, 60 miles across. Or Mount Dutch supervolcano at the North Pole, the one we discovered a couple months ago, or a month ago. That's 68 miles long and 40-something miles wide. So, what can I say about this? This is 230 miles wide. And it's not the only one. There's another one to the north. Let me show that to you. Let me back this out. And you see this here? Okay? See this circular shape here? Now I want you to pay attention to the sides. And it goes down here to the south, and it just like the other one, it bends down and around it. I'm going to show it to you just so there's no doubt about it. Well, if I can get the line measurement tool to point. Doesn't seem to want to do it. Let me zoom in a little bit. There we go. Okay, and take it around the edge. Here's the edge. Goes right down, matches up, curls back around. Then you have to really zoom in and see. You have to really go in and look, and you see that it makes the bend. And it bends back up here to the north. It's separated by a ravine of some kind that breaks through here and curls back around to the northeast, and it follows the range. Here, it slopes down. And if there's any doubt about it, you can move your mouse from down here at the basin, or if the lake at the side of this large oval-shaped depression, or down here to the, or actually I shouldn't say down here, it's to the northwest, so up here to the northwest. But as I move my mouse across, look at the elevation. Goes up and then comes back down, just like the other one. So it's another oval, circular-shaped plate bulge formation where we have another sulfur dioxide plume coming from. Let's get back over to the Earth Null School map. Now this takes us into current. and a wildfire there at that location. I would say the wildfire is not caused by any kind of wildfire source that you would normally expect. That's sulfur dioxide coming from a huge amount of sulfur dioxide. If it is a wildfire, then we have underground oil deposits burning. That would be the only other option. So we have two options for the production of CO2, carbon dioxide, and SO2, sulfur dioxide. That would be some kind of burning material that's not a wildfire, magmatic in nature or fossil fuel in nature. Since there's no giant oil pumping operation there and there is something burning, that either means magma rising, releasing sulfur dioxide, causing the burning, or wildfire burning a natural oil deposit, and that's not good either because that means something underground is burning. That would explain the large puffs of CO2 coming off, because it would be storing up down below the CO2 as the burning would be spreading out across the area. It would be burning far below under the ground and then releasing these in belches. So, what more can I say, guys? What more can I say? That's what's going on there. Now, one more thing. Let me open this back up. We'll go into the international earthquakes which struck, which is really kind of another spot of the forecast areas that have been hit. And let's just quickly see how many people are here in chat before we go any further. It looks to me like there is about 500 people right now in chat. That's a noticeable increase as well, not just in the sulfur dioxide emissions, but the amount of people that are in here. That's interesting. Well, here in the West Pacific, guys, we can go over the earthquakes, which we talked about since last night. Right now, again, we're looking at the USGS feed. To get a fuller picture of what's going on, we need to look at the USGS and EMSC feeds. And when we take a look there, we'll see all the smaller earthquakes recorded by the Europeans and the USGS, which USGS misses a lot of those. We've already covered the US, so let's go look at Japan, Southwest Pacific, West Pacific. We have new deep earthquakes, which finally struck. We talked about this last night about watching out for new deep earthquakes to strike, and they would determine where our watch zones will be for the next few days. And as you can see, the 4.8 raised high off the globe or higher off the globe, and the 4.3 to the west. Those spots, next to those spots, are the spots we have to watch for 1 to 2 magnitudes larger than the deep movement. So if we're looking at a 4.8, then we need to look for a shallow 5.8 to 6.8 to strike in a nearby silent zone in the next couple days. Over here to the west, the 4.3s, the deep 4.3s, we need to watch for a shallow 5.3 to 6.3 in a nearby silent area. This takes us into Sumatra, nearby silent area, and Taiwan and North Philippines. Taiwan being struck by a Category 4 tropical event right now, and I don't really do the weather thing on here, so if you guys are interested in that, we'll try to post some links later. Don't have many viewers in Taiwan, but just be aware that's going on. Sometimes we see earthquakes develop out below these tropical systems. Now, up in Japan, take a look at it. Do you see the activity here? This is spread out along the Izu Ridge, the most activity to the south, spreading up to the north to the west of Japan, near China and North Korea, and then we have the 4.4 striking just northeast of Tokyo. Well, this means that the whole area is in flux, and the nearby areas should move that haven't moved yet, and it'll be 1 magnitude larger than the largest of the bunch we see here, at least around Japan. So it takes us up into the mid-5 range, and it puts us at Tokyo to the south and Hokkaido to the north. So it's 2 small areas in Japan over the next 2 days that should see mid-5, again mid-5, just 1 magnitude higher, unless we see deep earthquakes strike in the next day or two. But right now we're basing it only upon the nearby shallow earthquakes, and when you get combined totals between this will take us into the 5 range in the nearby silent zone. Again, that tropical storm over Taiwan, have to watch for the relation on that. Some people deny the relation between the tropical storms and the earthquakes that strike underneath them as they're hitting, but, it is what it is. Over here in the west, we get over towards Europe, and then we're going to be drawn towards the earthquakes that have struck in South Europe and the Middle East. This is the swarm location near Kyrgyzstan, western China, South Russia, North India, west of Nepal, that keeps swarming, and that's a result of the 6.5 that struck last week. That'll carry on for another week, It's the spot that gave way finally after 2 to 3 weeks of no movement. So 6.5 built there. Well, since then it's pressed to the west, and the Europeans show us the last 50 European quakes. So we're not getting the full picture of what struck, but Turkey got hit over and over again over the past several days. Since Turkey got struck, then we saw Italy get struck, which isn't on the map here now. I talked about that last night, the 3.6. Since then, Switzerland has been struck multiple times. North Italy struck by 2.8, but Switzerland. And Switzerland, multiple beam drops from CERN. We've talked about that at length, what it means when the beam drops occur, and they're using nothing more than very powerful microwave systems inside of CERN. Those beams that they're powering are powered by banks of klystrons, and that's just a device that's used in radar systems to generate high-powered microwaves, and they use those in CERN to collide the waves and collide particles, see what happens. Central America, South America, be aware that the new volcanic eruption that occurred in Mexico at Popo is accompanied by a volcanic plume that's occurring. And let me just get you back over and show you that on the wind map. This is really interesting too, guys, because every time we see this happen, and I don't have it open, dang it, 1 second. Okay, let's just make sure you guys can see this. You sure can. We're going back to the Earth Null School wind map, and we will turn on the SO2 yet once again. This is important. This is important for people down in Mexico and for people on the West Coast. We'll zoom in. This is real-time SO2 feed, sulfur dioxide. And you see this dark splotch here in Mexico? Now, we can get the coordinates on this. We can do the same thing that we've done for all the others. Get the coordinates from Earth Null School and put them in on Google Earth. And I did this already. We've done this multiple times, so I'm already aware of what's there. I'll just do it to show you guys. This is taking us in on central Mexico, north of Mexico City. Okie dokie. And we'll back this out ever so slightly. And this spot right here has been producing a large sulfur dioxide plume for the past day to 2 days. Now, if we were to go back a day, you would see that there was a large sulfur dioxide plume to the south. And maybe I should do that. Let's open that back up so you can see yesterday. Or maybe I should just zoom it in so you can get a better picture on this. This spot right here to the south. And let's back it up so you can see what we all looked at last night. I need to go back one more. No, I need to go forward one more. This is real time, guys, so I'm just, you see the mess ups as they go. This spot down here to the south. All right, well, the spot to the south is Jocotitlan, and it showed more intense over the last day and a half, but this spot right here is a volcano that hasn't erupted in 700 years. And the other spot to the north, God knows what's there. There's nothing there of any importance that should be producing large sulfur dioxide plumes, no mines, no pumping operations of any kind. So what does it mean? It means that there's a natural release of sulfur dioxide gas coming from below the location. And then when you get up to the northeast of there and to the southeast of there, there's all kinds of volcanoes. And I mean, it is littered with old lava flows. You can make them out still here. These are not just mesas. These are old lava flows. So it's next to an old volcanic field. Could the magma chamber have moved over time? Maybe. But regardless of that, it's causing sulfur dioxide plumes to appear here. Additionally, over to the west, over at Barcena volcano, we still have a small pocket of sulfur dioxide being emitted from the volcano there. And it's due west of this location, so we can just literally go due west, and here's Barcena. And Barcena emitting a noteworthy sulfur dioxide plume for the last 6 days, right after an earthquake struck. So an earthquake struck there, then the sulfur dioxide plume appeared there. So altogether, the sulfur dioxide plumes, if you add them in together with what's going on up in Canada, that's just too strange. The CO2 plume, that's telltale that there's something going on down below, and the sulfur dioxide letting us know there's expending some kind of fossil fuel or burning rock. Well, then that, of course, points towards volcanism. It's really kind of troubling to see, and of course the professionals will never tell us. They will never disclose that. They might never ever talk about it, but you guys heard it here, and my cat, I'm sorry about that. We're wrapping it up anyways. So how many people are in here? About 507, 510 people in the chat. I would appreciate it if you could get the word out that we're watching still on the West Coast down to California, and that we're watching these sulfur dioxide plumes to see what happens, because it's a new discovery. That giant dome, I looked all over for information to see if anybody had ever noticed a giant dome-shaped structure up in northern Alberta, and there's nothing about it. That dome might not be volcanic. It might be petroleum products. It might be natural gas and oil causing that upwelling. It could be an undiscovered massive dome containing huge amounts of oil and natural gas. And then we'd only be seeing these small burn-offs occur every once in a while, and they think they're wildfires. They could be, a lightning strike comes in, penetrates into the dirt, or, a couple layers down into the soil, ignites an underground oil fire that burns and causes a real wildfire. That's possible too. But the sulfur dioxide is only, you can check with any professional. Wildfires don't produce sulfur dioxide or CO2 in mass quantities like what we saw when we were just looking there with the big blue bulge over the area. That is being emitted in puffs, and we just saw a couple hours ago it disappeared, and now it's reappeared. So it's puffing off CO2, belches of CO2, and belching off sulfur dioxide, and burning at the same time. So, I don't live there. It's so far up in the back, far northwest. It's up in northern Saskatchewan, the Northwest Territories. I'm sure somebody could go there and see what's going on. It would be very dangerous, especially if there's underground fire of any kind that's burning off oil. Now, would they ever admit that? It would be natural. It's not like man-made oil operations there would be burning. We're talking about up from the ground comes bubbling crude. That actually still occurs in nature, and it's shallow. There's some shallow deposits that could be ignited if a wildfire is going by, or if a lightning strike causes a wildfire, and then the wildfire burns into a part of the forest that has access via peat moss or peat bog, catches on fire, and next thing you know, that oil deposit could actually be burning, or coal. That bulge could also be coal, oil, gas. It might not be magma. But whatever it is, it's a 230 mile wide oval-shaped bulge. At the same time all that's going on, let me draw your attention to something that we noticed going on over in Russia that confirms that something strange is afoot. And let me turn on the CO2 again. Now, again, we would not expect carbon dioxide to be released from wildfires or anything of the sort. So with the CO2 feed on, let's see if this is working at least. Well, CO2 not working all of a sudden. Carbon monoxide working. CO2 feed is now down on earth.nullschool.net. No data. No data, guys. CO2 removed. I'll be dang. No data. You see it in the upper left-hand corner? Others are loading. See it? Carbon monoxide. But CO2 levels are now not being reported. They have been removed. The feed has been scrubbed. I'll be damned. See if you guys are getting the same. See if you guys are getting the same warning or the same results. Let me go post this into the chat room. I'm glad this is happening on the live stream. I hope it's not just me. Because if it's just me, then I have to reload everything here. Let me post it. There we go. Let me know what it shows for y'all. Yes, I said y'all. I'm from Missouri. No data. You've got CO2? Okay, let me hit refresh again. See what's going on. No data. I'm showing no data. Ah, there you go. Everybody else, no data. There we go. All right, well. Go ahead and rewind, guys. Rewind and hit save, because that's how things go. When you start to find stuff that conflicts with anything that they would possibly want you to know, then they're going to censor and hide the data, and they'll have some explanation for it. Oh, you watch, they'll have some explanation for it. I was going to show you what we discovered over here in Russia, which I can still show you the formation and what's up. So let me just bring you over here. Hold on. Oh boy, oh boy. I was just going to show you all that, and that just sucks. Okay, let's go back over to Russia and show you the spot that is a giant. Now, this put off earlier today from right here a large burst of CO2. Not as big as the one over in Canada, but nearly as big. It was showing up as white. Okay, and normally that wouldn't show up at all. And I was looking at the area, and I thought, this kind of looks a little bit strange, because up here to the north we have an oval shape, and down here to the south we have an oval shape. And they're connected by a ridge. So I decided to come in and measure it, and let's just go ahead and do that. Okay, first of all, let me show you what I'm talking about in case you're missing it. All the way down and around and back up, and then back up through here. We can zoom in and you can see where the fault zone and river exists that falls into that fault zone. And it comes right back up here and curls back around. Well, how big is this? That's 1,380 miles long. In kilometers, for my European and international viewers, 2,226 kilometers. But miles, 1,383. And wide, it's exactly half that. It goes into about 600 miles wide. So 1,300 miles long, 600 miles wide, and down here on the southeast edge, gave off a giant CO2 release today. And we can't see the CO2 feed. Maybe we can in a minute. Maybe it's, I don't know what's going on here. Whoop. Let's go back here. I don't see anything else going on. That's just too weird. That's just too weird. CO2. Repopulate? No data. Still no data. Well, that was the telltale sign that something was going on, and they removed that. That was the smoking gun. That one's like, why is there CO2 being emitted from there then? Right? And sulfur dioxide. If they kill the sulfur dioxide feed next, then you really know they're trying to hide it. Oh boy, oh boy. Well, to me, that's the smoking gun of smoking guns, the missing data all of a sudden as soon as we're looking at it. So how many people are in here now? I just want to make sure. I want to make sure that we're reaching the maximum amount of people. It looks to me like we have about 520 people in here. I think that's enough to get the word out. If you guys could share this feed right now, share it out and say, hey, rewind the feed and look what just happened. Look what he was showing, look what he was talking about, and look how they just censored the feed. If you guys could, I'd appreciate it. There's a share button down below, so it's real easy. You can do Facebook, Twitter, whatever. And if you could put on your blog, if you guys got a website, you can embed this video by just taking the YouTube video address and putting it on your website. But get the word out. This is why I do what I do, and because now we can't see a critical option that's going to tell us what's going on, I would say that's deliberate. That hasn't just... How many times have you seen that, guys, in the time of looking at WinMap? I've looked at it a long time, and that doesn't just happen automatically or randomly. And I just want to encourage you guys to also pay attention to the earthquake activity that I talked about at the start of this update 37 minutes ago, where I told you to watch on the West Coast, and we need to watch our silent zones for 1 magnitude larger than the current movement is going on. Okay, so it's a lot going on right now. And for them to try and do that, we can go check the wildfires. I mean, you guys are free to go check the wildfires and compare to where they say they're occurring and they're not. And as of before I just got on this broadcast, I'm not going to bother opening Intellicast because they have this rule about Intellicast and showing it on any kind of thing that runs an ad. Anyways, I won't go into there. But on Intellicast, you can go look and you can check the wildfire reports. And the spot that we're talking about with the big CO2 emission, sulfur dioxide emission, and carbon monoxide emission, that spot didn't have a wildfire marked over it, even though Annimatronic has a picture of it. So that wildfire reporting tool that everybody's using isn't accurate, is not accurate. It's either lagging behind or they're just not complete at all, not thorough. So we can't go off that. We actually have to go off of what's being detected. And what's being detected? Sulfur dioxide, carbon dioxide, and carbon monoxide. We would expect carbon monoxide from a fire you would not expect sulfur dioxide or CO2 in huge bursts. So what can I say? Guys, we will be back in an hour to do a question and answer session. If you have a question, you can go over to my Facebook page, and I will get a link for that right now and put it into chat so you guys can submit your questions, and I will answer any questions that you have at the Q&A session, which I've been doing every night for at least an hour each night. And I aim to do that going into the future, so it's not like I'm just going to stop answering questions. I will be here, and I will answer questions for all of you each night, at least when I can be here. And we've gotten some really good questions, which led us into some huge discoveries. For instance, the 6.0 earthquake in Hawaii, or the sulfur dioxide that we discovered coming from Barcena volcano off the west coast. No media picked that up. If you guys have a question, here's where you submit it. I'll put it into the chat room right now. And that's a link to my Facebook page. It's a public post. Ask your question. I'll try and get to as many of them as I can, and I'll do them in order. I'll also check the chat room. So if you guys are in here tonight for the Q&A, I'll have the chat room open too. So if any interesting questions come up while I'm answering the questions from Facebook, and for the people who don't have Facebook also, you can ask questions on the chat. We're not turning that off. So overall, it's just been a wild couple days. All the areas that we forecast have been getting hit. Professionals say earthquakes cannot be forecast. Of course, we know they're wrong. We know they're wrong. And, what do we have here? What do we have here? They just put a new deep earthquake on the map that's 2 days old. You guys just saw the deep earthquakes that I showed you, correct? Yes, you sure did at the start of this broadcast. Now they have just added a deep 4.6 from July 4th, yesterday. How about that? How about that? Well, okay, so they just added a deep 4.6. Let's get the coordinates on this and the depth. 367 miles deep, 591 kilometers. Well, that means we need to watch in the next day. It's already been a day, and we haven't seen any shallow or large. Oh, no, we did. Never mind. We did see shallow or larger movement nearby. 3 different 5.2s. Or 2 different 5.2s. And a deep 4.6. Well, that's not all she wrote on that. Now that I see that we have a new deep earthquake there, just populated on the map, they put a day-old earthquake. It's like day-old bread. They put a day-old earthquake on the new earthquake feed. Just slipping it in there real quick, I suppose. Well, that ties in with the earthquakes that already struck, but we need to watch for 1 to 2 magnitudes larger, which, again, like I said, takes us up into that mid-6, possibly low-7 range. Oh, wow. Well, I'm glad I checked. I'm glad we didn't sign off yet, because that just came on the map. Look at it. Doesn't even fit on there. It's one of the deepest earthquakes we've seen in the past several weeks, actually. Okay. Well, that's all she wrote. Guys, get the word out. Share the links. If you're not subscribed, please subscribe. I know everybody asks you to subscribe to their channel. This one's just for earthquake updates. So if you're interested in geophysics, you can subscribe. I'll have the live stream going. I'll try and do as many updates on my channel as possible. We get the Europeans here. We've got the USGS here. So you get combined feeds that you do not get on the USGS. Half the earthquakes that you see on here are not reported by the USGS, meaning that you're not getting a full picture at all on the USGS website. If you want a full picture, you can come to sites like this, mine, or you can combine all the feeds yourself and try to get them onto a globe somehow so you can see them all at once. But that's what I'm doing this for, so we can document earthquakes as they happen. I want to welcome everybody who's new into the chat. We discovered a large bulge dome shape in North America, far North America, the north tip of the North American Craton, north of Alberta, and the southwest and northwest territories. That's a huge discovery in itself. The fact that there's sulfur dioxide coming from there, the fact that the feed is now hidden and we can't see the CO2. I almost want to check it one more time. You know, don't you guys want to check it one more time? Hold on. Let me post it in chat again. Oh, wait, I don't have that. All right, hold on. Live streams. Losing my links on live streams. Let's go back over there, turn it on. I'm not even going to turn it on for you guys. I just want to see if it's back. Ah, it's back. It's back working. Hold on. Here it is. Here's the CO2 feed. Now back. Data available. I was getting ready to sign off and they turned it back on, right? That is just kidding. All right, so let's zoom in on the area one more time. Oh, gotta wait for it to populate each time. There we go. Now this is carbon dioxide. Let's take it back. Take it back again. Take it back again. Take it back again. See this? See how it appears in a large bulge? Right over the area in question. Okay, you see that there. All right, so that's Canada. I'm glad it finally populated again. I'll call less conspiracy now that it's showing, but you know, we're freaking out over it, so they got to turn it back on, right? Now let's get over here to Russia and show you the same location. And we'll back this up. Okay. There's a bright blue spot here in Russia. We'll zoom in just a little bit more. Whoops. Well, we just lost it. There it is. Okay, I'm going to get the coordinates on this and show you what's there. The same way that we did it before, grabbing the coordinates from down here in the lower left-hand corner, taking them over and putting them in on Google Earth. Same thing. Now, I was just talking about Russia, right? We were just looking at it, correct? So here's the spot producing this large CO2 plume. Nothing nearby, and I mean nothing. We're back out here in Siberia, somewhere up here in, you know, the nether regions, or actually not, Irkutsk, but it's right on the edge of that large oval-shaped 1,300 mile long, 600 mile wide bulge, and you can move your mouse over it and see that it bulges up here to the north and then slopes down here, or bulges down here to the south and slopes up here to the north. And again, we'll get that measurement tool on there to show you 1,380 miles long with our shape all the way down to the south and up to the north. And the CO2 plume appearing right here on the southeast edge where there is nothing, and I mean absolutely nothing, that could be producing that except for a natural release of CO2 coming from inside the Earth. CO2 could be a byproduct, of course, of burning fossil fuels or underground magma movement and natural Earth processes. It's a real mouthful, but there it is. So get the word out, let everybody know, share the video, like and subscribe if you aren't already, and I want to welcome everybody who's new to the chat room. You're welcome to use this all day long, even when I'm not here talking. Nightly updates at 10 p.m. I'll be back in an hour to do question and answer. So cheers, guys. Much love. Be safe. And, of course, let me finish the broadcast by telling you, have an earthquake plan ready. Be prepared just in case. You may never have to use it. Just know what to do when you're inside of a structure and something over a 5 strikes. If you get under the 5 range, you might get a few broken objects, a few broken bricks on the outside of your house. But when I'm talking about earthquake preparedness, you need to know what to do inside of a building when a larger earthquake strikes. There's broken glass that'll be on the floor. There's doors that might not open. If there's structural shift, be aware of those things now. Know what you'll do in times of emergencies. So that way when an emergency comes, you're already prepared. And everybody else who's running around all crazy around you in your neighborhood, or wherever you are, you will know what to do, and you'll have a game plan you'll already be prepared where other people aren't. It's a lecture, I know, but come on, you gotta be prepared. Look at what's happening around the planet right now. Wow. Wow, wow, wow. So, if anybody can explain to me how a wildfire up in Canada can be producing large amounts of sulfur dioxide gas and CO2 in bursts coming out of the ground, I'd be interested to hear what the explanation is. There's two options in my opinion. One, magmatic. Two, natural fire burning an oil deposit of some kind underground. Those are the only two things I think that could produce that amount of sulfur dioxide and that amount of CO2 in addition to the carbon monoxide of the burning material itself. So you do get carbon monoxide off wildfires and off burning petroleum, but you also get sulfur dioxide and you also get carbon dioxide off of burning petroleum. The taiga, the Russian outback. Yeah, I see that in chat. Yeah, the taiga. I've heard of that before. It's kind of like a tundra type, not frozen, but semi-barren wasteland, non-populated by many people at all. So that all exists there. Many thanks, guys. Cheers. I'll be back in an hour.